So now I just want to talk to you guys real briefly about how when calculus misassumes their axiom, which states that there's 360 degrees around any point on the surface of the sphere, they're incorrect. Calculus differential equations, they try and measure the difference between things, and they get to such a small difference that they say that's close enough, that's good. And things work, and they're beautiful, and it's not necessarily a wrong way of doing things. It's just that when we're getting down to the level of the angstrom of the atom and those types of measurements, and then we're trying to ratio angular momentum, I'm just pointing out that they're incorrect because there's always 720 degrees divided by the total number of vertexes in that system less than 360 degrees around any point on the surface of what seems to be a sphere. The tetrahedron has 3 triangular planes surrounding each point. They're equilateral at 60 degrees each. 3 times 60 degrees is 180 degrees. Each of these tetrahedrons has 4 vertexes. 720 divided by 4 is 180. 180 plus 180 is 360. So that's how you get 360 degrees around any point on the vertex of a tetrahedron. The octahedron has 4 triangles around each vertex at 60 degrees each equals 240 degrees. 720 degrees divided by 6 is 120. 240 plus 120 is 360. 720 degrees, by the way, is in synergetics in ways considered like one quanta module of energy, because it's the total angular variation on one tetrahedron, which has 60 degrees on each of its 3 triangles around each point, and there's 4 points given it the 300 and given it the 720 degrees. So the vector equilibrium, you've got 2 squares with 90 degrees each and 2 triangles with 60 degrees each. 180 plus 120 is 300. 720 divided by the 12 vertexes is 60 for a total of 360 degrees. The icosahedron has 5 triangles around each point times 60 degrees. In each triangle is 300 degrees around that point. 700 degrees. 720 degrees divided by 12 is equal to 60 degrees. Totals 360 degrees. We take a carbon-60 molecule. It's cool because we can blow these up now. We've taken pictures of them. Here's a model of one. This has 60 Buckminster Fuller buckyballs. So these are magnetic balls that you can buy. So when you connect the 60 balls into the form of the carbon-60 molecule, you'll notice that around each point, around each of these spheres on this molecule, you have 1 triangle, 2 squares, and 1 pentagon. The 2 squares at 90 degrees equal 180. The 1 triangle at 60 equals 60. The 1 pentagon at 108 equals 108 for a total of 348 degrees of angular variation around this point on this sphere. That equals 348 plus the 720 degrees divided by the total number of vertexes, 60 vertexes, equals 12 degrees. Add those together, 348 plus 12, 360 degrees. So the universe doesn't use calculus. Man does, and he's real close. There's nothing necessarily wrong with what he's doing. I'm just pointing out that universe does not use pi or calculus to design its millions of things and illions of things. When a child blows that bubble from the soap, that bubble has an exact number of molecules, an exact number of vertexes. If we could freeze it in time and look at it, we'd notice that each of those molecules then has an exact angstrom of measurement between its closest packed next molecule. So if we wanted to, we'd be able to count up the billion molecules or atoms in that bubble, divided by, or divided 720 divided by that billion. You have a slight amount of angular variation on that sphere. I want us to keep that in mind when we are talking about things like 1/137th of the angular momentum remaining free and uncommitted during the coupling process, that extremely slight variations could be due to the different means by which universe is calculating, and Bucky thought that he had found the coordinate system that nature uses to design its millions of things, and that's the coordinate system that I'm using in order to explain how and why the numerical interrelationship patterns within the nucleus of the atom exist the way that they do. Why does 1/137th ratio to the mega electron voltage of the proton in whole rational units? Why does the mass of the proton and the mass of the neutron and the mass of the electron and Planck's constant and the fine structure constant all ratio in whole rational units of vectorial interexchanges within the polyhedrons which we've been discussing? You recall the formulas which show symmetry. And quite frankly, they're the most beautiful things I've seen in the universe. What symmetry, right? So let me double check and make sure that we're still working here. Yep, seems to be. Touch it. So I know that we went over this once already. I'm just showing it again. Got some different boards to help us understand some things. I'll be discussing some more in just a few moments. Thanks for your time, you guys.